So have you ever actually stopped to think about just how much of our modern world is held together by completely invisible forces? Seriously, I'm talking about things we literally cannot see with the naked eye. Yet we engineer them, we scale them up across entire continents, and believe it or not, we even sculpt them into art. I mean, what on earth could levitating trains, towering concrete buildings, and glitching sound art possibly have in common? Well, it all comes down to how we humans have somehow figured out how to master the unseen. Welcome to This Explainer. Today we're exploring the architectures of the invisible, and we're going to synthesize three wildly different areas here. We've got the extreme micro-level precision of laboratory engineering, the massive macro-scale world of global transportation, and then the really fascinating realm of avant-garde art. By the end of this, you're going to see exactly how these exact same invisible forces are manipulated to either eliminate friction entirely or deliberately create it. Okay, let's dive into the agenda. First up, measuring the magnetic gap. Then, part 2, scaling up maglev 2024. And finally, part 3, sculpting invisible structures. Section 1, measuring the magnetic gap. Right, so to kick things off, we need to totally shrink our perspective down to the micro world of laboratory engineering. We're looking at magnetic levitation platforms, or MLPs. These are crazy systems used for things like zero-power gravity compensation or highly sensitive vibration isolation. And here's the kicker. They rely entirely on maintaining a perfect invisible gap of exactly 104 millimeters. Now, in our everyday lives, 4 inches, it's nothing. But in the world of magnetic levitation, hovering 104 millimeters with zero physical contact is a massive, highly unstable chasm for a platform to maintain. The platform itself, the mover, is suspended by permanent magnets, but while it's stable vertically, it's passively unstable radially, which basically means it naturally just wants to slide sideways and crash. To keep it perfectly centered, the system needs active electromagnets, and those magnets need constant, flawless data from position sensors. Now, what's really interesting about this is the literal showdown between the two main ways we actually measure that gap. On one side, you have the eddy current sensor, or ECS. And this thing is an absolute powerhouse. It uses a high-frequency 3.1 megahertz electromagnetic signal, giving it a position tracking precision that is literally 10 times better than the alternative. The signal-to-noise ratio? Also 10 times higher. But it has one fatal flaw: the Faraday cage effect. See, if you have to enclose your levitating platform in a conductive chamber, like for a vacuum experiment, those conductive walls disrupt the high-frequency magnetic fields, rendering the ECS totally blind. And that is exactly where the reaction force sensor, or RFS, steps in. It's way more versatile. It works perfectly inside those conductive chambers, even though you do have to sacrifice some of that ultra-high precision. And we really have to remember the stakes here. In closed-loop control systems like this, precision isn't just some nice-to-have metric on a spreadsheet. It is the literal difference between a smooth, perfect hover and a catastrophic crash. These sensors must accurately measure not just the displacement of the mover, but its tilting angle too, and instantly feed that data back to the electromagnets to stabilize the whole thing. It's essentially this invisible architecture of data and magnetic force rebuilding itself thousands of times every single second. Section 2, scaling up, maglev 2024. So what happens when we take that super delicate 104 millimeter lab experiment and stretch it across hundreds of kilometers? Well, in September 2024, the world's leading minds gathered for maglev 2024, the 26th International Conference on Magnetically Levitated Systems and Linear Drives. Set against this gorgeous, futuristic skyline in Malmö, Sweden, this was a massive milestone. Because of the pandemic, this was actually the very first face-to-face maglev conference in 6 years. And honestly, it's a beautiful contrast. You've got this brilliant, warm human element, researchers from all over the globe shaking hands, grabbing coffee, collaborating to build the cold, frictionless, ultra-high-speed transit networks of our future. And this brilliantly illustrates the sheer scale of the field right now. It's totally sprawling. Track A dove straight into the hardcore engineering. I mean, just imagine calculating the aerodynamic loads on a train when it's blasting by at a mind-bending 600 kilometers per hour. Track B looked at actual real-world projects, from the TUM Hyperloop demonstrator over to the superconducting maglev vehicles for Japan's Chuo Shinkansen. And then Track C? That tackled the really critical human questions, like, are these systems truly sustainable? Do they actually help grow regional economies and benefit society as a whole? The big takeaway here is that whether you're in a lab tracking a platform with an eddy current sensor or you're engineering a massive superconducting train, the core philosophy is exactly the same. We are engineering the invisible gap. We're removing physical contact, we're removing friction, and we're replacing it all with carefully sculpted magnetic fields. The whole goal is to make our physical world as incredibly smooth and frictionless as possible. Section 3. Sculpting invisible structures. Okay, let's pivot for a second. If engineers are out there using invisible forces to eliminate friction and noise, what happens when artists get their hands on invisible forces to do the exact opposite? This brings us to a wildly fascinating emergent aesthetic known as sound-based brutalism. Just as those engineers are rigorously structuring magnetic fields, these artists are rigorously structuring sound waves. But instead of aiming for smooth, silent perfection, sound-based brutalism focuses entirely on the materiality of raw, quote-unquote, anti-beautiful sonic materials. To really wrap our heads around this, we have to jump back to the 1950s. The architectural movement of brutalism, which was coined by Rainer Banham as the New Brutalism, was this post-war reaction against soft modernism. Inspired by pioneers like Le Corbusier and his use of raw concrete, brutalism prioritized showing off the clear structure of a building, valuing raw materials exactly as they were found. Now, historically, the public hated it, and let's be real, a lot of people still do today. It was called cold, stark, monolithic, even surly. But actually, that was exactly the point. Banham highlighted that the movement deliberately embraced this totally anti-beauty aesthetic. So the crucial point is, how does this translate to sound? Well, sound-based brutalism takes the raw, unprocessed materials of noise and treats them architecturally. It leans heavily on composer Pierre Schaeffer's concept of the objet sonore, or sound object. The entire focus here is on the material over the musical. These artists, they aren't trying to write catchy melodies for you. They're taking harsh, grating chunks of noise and stacking them up with the exact same intense, quantized structural rigor as you would a literal concrete building block. A perfect example of this is the Brutalist Noise Ensemble, which is an audiovisual project by Mo H. Zarei. Fun fact, Zarei actually grew up in a brutalist residential complex in Tehran, which gives him this really deep, personal connection to the aesthetic. His project literally takes glitch music out of the slick, frictionless digital world of computer and forcibly drags it back into physical reality. He designed these incredible geometric, sculptural instruments with aggressive names like the muter, the rippler, and the rasper. And through these machines, he translates non-beautiful, abrasive sounds into rigid, rhythmic, physical structures. He is quite literally sculpting with noise. It is just an incredible juxtaposition when you take a step back and look at the whole picture. On one hand, you have the brilliant minds of Maglev 2024, using ultra-complex sensors and superconducting magnets to completely eliminate friction, trying to build us a perfectly smooth, silent, hovering future. But then on the other hand, you have these neo-brutalist artists taking the exact same invisible medium, sound, and deliberately packing it with as much raw friction, noise, and abrasive materiality as humanly possible. Yet, at the end of the day, both disciplines rely on a profound, masterful control of the invisible structures that surround us. Which leaves us with a pretty lingering thought. We've seen how magnetic gaps are meticulously measured in labs, how they're scaled up to levitate 600-kilometer-per-hour trains, and how the invisible waves of sound are sculpted into literal concrete-like blocks of noise. So it really makes you wonder, as you go about your day to day, what other invisible forces, from the unseen data routing your commute to the hidden algorithms shaping the media you consume, are being secretly engineered, structured, and sculpted all around you. Keep your eyes and definitely your ears open. Thanks so much for joining me on this explainer, and I'll catch you next time.